Thank you very much for waiting. We will resume the session. Next, we will proceed with the session titled Low Power Consumption Devices Required in the AI Era. Mr. Ram Velaga, Senior Vice President and General Manager at Broadcom, and Mr. An-ji Hwang, Co-founder and Senior Advisor at Acton Technology, and Mr. Tomizawa, and the moderator, Mr. Michinori Sato, Executive Officer and Asia Pacific Communications, Media and Entertainment Sector Leader at Deloitte Tohmatsu Consulting LLC. This will be a presentation in a panel discussion format. Please note that this session will be conducted entirely in English. Simultaneous interpretation receivers are available for those who require them. Channel 1 is Japanese. Please take your seats.
Good afternoon. Thank you for your time this afternoon. My name is Ram Velaga. I'm hoping this clicker will work. It's not working.
Hold on a second.
Oh. I will facilitate.
Oh, yeah.
Hello, everyone. My name is Michinori Sato from Deloitte Tohmatsu. I'm responsible for the telecom, media, and entertainment sector across the APAC region in Deloitte. Having closely followed the ION initiative for years, including the great experiences in the Kansai Expo or by the good performance by Perfume, I'm very looking forward to facilitating the meaningful insights from all of you and for all you today. And we've heard that from Hoshino-san and Tomizawa-san regarding the future outlook of the PEC and CPO switches as part of their strategies. Like to hear deeper real voices from these three companies today. They are deeply involved in realizing the ION initiative and like to hear especially around lower power consumption devices. Today we have, as she mentioned earlier, Ram-san and the AJ-san and the Tomizawa-san. So to begin, like to have the brief self-introduction from the both companies, including the their product strategies and the history of their collaboration with NTT and expectation for NTT. So firstly, over to you, Ram-san.
Thank you very much. Good afternoon. Well, one of the things I wanted to share with you is research published by McKinsey that talks about the next few years. There's almost 124 gigawatts of power coming online to support everything that is happening in AI. And when you think about this 124 gigawatts, that is roughly over 70 million GPUs or XPUs. Okay. Now, just to give you a couple of data points to give you some context on this, some of the large language model companies are at a minimum expecting their compute capacity to grow by about 3 times every year. Some of them are expecting it to grow much larger than 3 times every year. But if you do the very simple math, for the next 5 years, if it grows by 3 times every year, you're basically looking at over 200 times today's capacity is what's expected in the next 5 years. This is a significant amount of compute that is being added in the world to support the large language models. Now, when you do these large language models, one of the things that you realize in machine learning is it is a massively distributed computing system, right? Because any one GPU / XPU, or what we call the accelerator, cannot do the work. You have to have many thousands, many tens of thousands of these accelerators connected together. when many of these accelerators are connected together, the network becomes the computer. This is something that Sun Microsystems had trademarked 20 plus years ago, almost 30 plus years ago, and they said the network is the computer. This is a picture of Google's data centers from the early 2000s. What you see here is when they built a very large distributed computing system, which is the search, what they did was they took a lot of the CPUs and connected them with the network. Okay? In this particular case, 20 plus years ago, the network is all based on copper, right? Because the speeds which were coming out of these CPUs back then are a fraction or a couple of orders of magnitude less than the speeds that we expect coming out of the accelerators today and in the next couple of years. So when the network is the computer, and then you look at these accelerator deployments, as Mr. Tomizawa-san has mentioned, you think of the network as three different kinds of network. One that sits inside the rack, and that's called scale-up. One that connects different racks, that's called scale-out. And then one that connects actually between data centers, and that's called scaling out across data centers or scale across. Now, when you look at these accelerators, one of the things that is interesting is each of these accelerators has HBMs attached to it. You've all heard of HBMs. Today shipping technology is HBM3. Tomorrow the shipping technology is going to be HBM4. Each of this HBM has roughly 10 terabits of bandwidth connection it has to the accelerator. So when an accelerator has 4 HBMs, it has 40 terabits of HBM attached to it, and that's the bandwidth. Next year, there's going to be 8 HBMs, each running at roughly over, close to 12 terabits. So what's happening is you may have 2 accelerators. Each of them has 100 terabits of HBM attached to it, 100 terabits of HBM bandwidth attached to it, and both of these accelerators now want to talk to each other. That's the amount of bandwidth that's going to be connected between these different accelerators. Just to give you an sense for how large this is, today if you think about a server that goes into the data center, you will likely have a NIC that is 50 gigabits per second speed. Now when you think about an accelerator, each of this accelerator could have 10 to 20 terabits of bandwidth coming out of it. You're going from 50 terabits to 10 to 20 terabits. Sorry, 50 gigabits to 10 to 20 terabits. So you're talking about almost a 200x increase in I/O coming out of an accelerator compared to a CPU. This is a lot of bandwidth. Now the other thing that's happening is when you're building a large language model, you want to create a cluster of accelerators all kind of working together, right? And when it fits inside a rack, it's called a scale-up. And typically today, a scale-up is less than 100 accelerators connected together. Typically, you will hear a number like 36 or 72. But these large language models actually want that size of the scale-up to grow beyond 36 or 72. They would like it to be 200, 500 in the future, over 1,000. Okay? So when you think about that problem and you say, okay, today when you think about an scale-up inside a rack, it's all connected by copper. And you are okay connecting by copper when you only are putting less than 100 accelerators inside a rack. But when you're connecting 200, 500, or 1,000 accelerators, it doesn't fit inside one rack anymore. You have to connect multiple different racks. So when you connect multiple different racks, you no longer can use copper. You have to use optics. So the combination of the fact that you have tens of terabits of bandwidth from each accelerator multiplied by either 200, 500, or 1,000 accelerators, and the fact that you cannot use copper anymore creates a massive opportunity for optics to be the choice of interconnect. That is why you've heard other companies talk about co-packaged optics is the way forward. And now when you think about that and you say, okay, there's a lot of bandwidth that's needed, so how do you solve this problem? First, you need to build the switches which have the bandwidth. And Broadcom today has this device that's called Tomahawk 6. It's a 100 terabit switch device. And this is going to be shipping in very large scale production next year. Now, it's great to have the switch chip, but then you need to have that connected to other switch chips. And you need all of these to be connected together if you're trying to create a scale-up cluster, let's say 512 or 1,000, right? So that's what you need to kind of think about as you walk away from here, is there's a lot of bandwidth coming from each accelerator. You want to connect at least 200, if not 500 or 1,000 accelerators. Copper is no longer going to work. And how do you do this? Now, obviously, you also have to be able to connect across data centers, not just connecting many racks inside a data center. So if you think about all of this, you say, okay, there are switches which are available, and Broadcom does a reasonably good job building these switches for sitting inside the rack, across racks, and across data centers. But what is really important beyond building switches is providing these interconnections between the switches, right? Because copper is no longer sufficient to create this interconnect between switches to create these very large clusters, either inside a data center or between data centers. That's where actually our partnership with the ION team goes for a few years now, where we both realized that this is going to be a very large market. If you think about the fact that the compute is going to grow, at least expected to grow at least 3 times every year for the next 5 years, so that means it's about 200 times larger than it is today. And you will need to connect across racks. Optics is the only way to do it. Broadcom took the approach of saying, let's pick some of the best partners in the industry, and the leading one there is the NTT ION team. And we said, let's work with the NTT ION team to build a co-packaged solution. Because when you're building these co-packaged optics solutions, a couple of things are extremely important. One, people who are leaders in technology, who can build very high bandwidth devices at low power but with significant reach. Number two, you're able to produce them with a very high quality and yield, okay? Because the volumes that are expected and needed in this marketplace are very, very large. And number three, somebody who's able to scale the production of these, right? We believe the ION team is very capable of delivering on all 3 of these, which is building the best technology, building it with the quality and the yield that is needed, and then being able to actually scale to very, very large volumes. Now, what's interesting is we've always looked at it and said, okay, will customers deploy the co-packaged optics as a possible solution into these very large data centers? And last week, Meta, who runs some of the largest data centers in the world, actually published a document that said they looked at co-packaged optic solutions, and they ran for about 1 million hours, and they found that this is better than running pluggable optics as the solution in the marketplace. So you also now have customers starting to feel very comfortable and confident about how to build large data centers with co-packaged solutions. Now, there was a question to Tomizawa-san previously that said, who's the competition in this space for NTT ION? And he very honestly answered the different players who possibly can play in this market. But one thing I would say to you is the following, which is when the market is so large, which it is going to be in the next couple of years, the end customer, which is the ones who's building the data centers, whether it is Meta, Google, or somebody else, they want to see multiple players in the market, because if they don't see multiple players in the market, they don't have the confidence to go build a large data center on that technology. So the idea of a silicon photonics, for it to be successful, you need multiple players. But we are extremely confident that NTT ION is going to be able to deliver on the best technology, the quality, as well as ramp in volume. And if they deliver on it along with the others, the market is big enough for multiple players to enjoy. And we are actually, that is why we have very strongly partnered with Mr. Tomizawa-san's team for a very long time, right? And then lastly, our relationship with the NTT ION team is not something that is recent for the last 3-4 years working on this particular product. It has stretched for a decade plus. And what we have seen is a consistent, delivery of products with high quality, high volumes, but also with the performance that is expected in the marketplace. So we are extremely happy that we have the 100 terabit switch available to be shipping in very large volumes next year, and for it to actually get deployed, that we have very strong partners in Mr. Tomizawa-san and NTT ION to be able to bring very low powered solutions and obviously very disruptive cost structures to our customers. So with that said, I want to thank you and hand it over to AJ-san.
Thank you, Ram. So over to you, AJ-san.
Good afternoon. And I haven't did this in my last 20 years. I think I'm the oldest man in this room. And so in front of Ram and Tomizawa-san, I cannot talk too much about technical. So in my section, I want everyone relax. It's not too much technical stuff. I just want to share with you and answer your question is why we want to do this. And can we start from this page? This is our new factory. And we built this factory to produce Ram's product. So all the parts that we build from this building is all Broadcom chip. And we take us about 2 years to build this building. 4 years ago, the building complete 2 years ago, and now the whole building is full. And whole building is produce AI-related server and switch. And what I want to say is my dream. Why we want to do ION. I know Tommy-san for many years, and I know Ragana-san, Shimazu-san about 2 years ago. They give me the assignment. Then I attend NTT RD forum, and I realized how much NTT have invested in optical. So I would want to say, without Broadcom, without RAM, it's no Acton today. But I want to say, with NTT and Broadcom, Acton will reborn. So $3.4 billion revenue is last year. And this year, we are shooting for almost 7 billion. It's almost double. I just want to echo what the Ram said about the market size. And so why we want to do this? Since the day one, our vision is access. We want everyone can access computing power. Everyone can have their PC or their server get connected. So it's our vision, is access. And our mission, basically this vision, our mission is to make the product and technology be very cost performant, effective. So it's cost and connection. That's our company. And so this is just what I try to say. Without Broadcom, without Acton today, and with the Broadcom and NTT, and the new Acton will reborn. The last one you see, the NEL, and which I've been working with Tommy-san for many years. Yeah, when I need optical help, I come to him. Yeah. So when I heard Broadcom and NTT doing this CPU, I'm very excited. So I immediately jump in and to build a box. Yeah. So I think many people know this already, so I don't want to repeat. But most important message here I got from the ION book is to have everyone can be connected to AI or time compute, urban and rural area. And the AI should be fair to all citizens. This is what I learned from Shimada-san last time I met him. And I think it's very, very important. And in order to realize this, we need a very advanced technology, which is from Broadcom, for NTT, and we are playing the role to build a box, to reduce the cost. Yeah. So I talk about my dream. So when I learned ION, I've been thinking about how can we apply this technology to Taiwan. Taiwan and Japan is very close, and in history, two countries have a very good friendship. So I asked Shimada-san to help me, ask all my good friends in NTT, see we can implement this ION technology in Taiwan. The purpose is to connect all the different AI servers in the different locations. So you don't need to build a very huge data center. You can just connect a different, even one single rack, and connect together and can be looked at as one data center. So that's the purpose. And what we want to try. So I saw this last time, and to continue to enhance this. And so we hope Japan and Taiwan, we can collaborate in technology in this AI application. And of course, the most important is the talent. So talent can share the knowledge through this AI server. Yeah. So we start to do the experiment. So we have the 4 locations get connected by ION. Yeah. So start from the Tainan. So if we say this is a science park, if we can have this science park condemned by ION, then we can have the Tainan and Taichung, all the different cities connect together. So this is user case. This is for enterprise. And this is the case for hospital. So now the hospital, they can access their data, and they can share the AI computing power. Yeah. Today, every hospital, they buy one NVIDIA rack or 2 NVIDIA rack, but they cannot connect together. Yeah, so the ION play a very critical and important and maximize the value of AI server. And this is real case in from a south part of Taiwan is the science park. And from this science park, then we will connect all the university. So actually fiber, Taiwan, besides the telco, they also like high-speed railroad, like electrical company, and the Minister of Education, they all have a fiber. So we want to maximize the value of the fiber by using the ION technology. Of course, I think everyone talking about this for the global, and I hope we can contribute a little bit stuff from Taiwan and stuff from our manufacturing. Yeah, and thank you to NTT, thank you for Broadcom. They continue invest advanced technology. So then we build this rack. So ION will connect to this rack. And so you can plug in the different memory and or the AI or server. Yeah, this is what we are doing. Yeah. So we take the open architecture. So the idea, also I learned from ION vision, they want to enable the more different technology and different vendor and to contribute to make ION very successful. So this is our small experiment. And so far it's doing okay, yeah. Of course, still a lot of technology we need to invest with NTT and Broadcom, yeah. And one example here is we're trying to do increase the port density. So like how to make one optical can transmit more data. Because to lay out the optical cable is expensive. So we try to maximize the capacity about 32 times. Again, this is NTT technology. This is the box we built. Yeah. Actually, this is assignment from Aragana-san. So we met about a year ago, and he started to draw his idea on the whiteboard. Then I'm a little bit crazy, and I say, we don't have this technology, so I find a company in Korea called INLC. I just acquired them, and to make the dream come true. Yeah. And this is, I think Ram already explained very well here. Yeah, and we'll make this product very successful. And again, cost, performance, and speed. Yeah. And thank you to everyone. Thank you, Tomiya-san, NTT, Broadcom, RAM. Yeah, without them, and we cannot have the good product. Thank you.
Thank you, AJ-san. And again, thank you, Ram and AJ, for sharing the very clear strategic directions and the tangible business trend, including the major players in the market and the expectation and some aspiration with NTT. I again, felt that technologies, including the CPO, are very critically important for realizing the higher bandwidth, lower latency, and the very low power consumption. Next, I'd like to pose a few questions from the AI market perspective. First one is around the additional growth market for the PEC or CPO, especially for the data center market. It is said that approximately more than 60% of data center investment are allocated to the ICT equipment, including the server and switches. As the data center market continues to grow, these related markets are also expected to expand. So in addition to this trend, with the advancement of PEC, how large do you expect to capture a market scale and share in the future? So firstly, Ram-san, how do you expect?
Okay, I think the way to think about is there is a relationship between the compute growth and the networking that goes with it. So if the compute grows and this whole AI is growing, the networking will go reasonably proportional to it. And especially as we discussed, as the scale-up part of AI scales, all of that is going to be supported by the switch and the switch bandwidth. Now, obviously from the optics side, the growth will be even faster because today most of the first hop connections between the accelerator and the switch is copper. But now you no longer can support copper when you're trying to do scale up in the order of hundreds up to 1,000 devices. So you've basically a couple of things going on. Compute is growing, but network is going to grow, slightly faster than compute because the scale up is going to happen on technologies like, Ethernet, which did not happen today. And then optics are going to grow even faster because today the scale up is happening on copper, and that is also going to move towards, more likely towards optics. So there's three compoundings that are happening here.
Thank you. So, Tomizawa-san?
Thank you very much. So according to the market analysis, in the ICT equipment, 30 to 40% will be for the server, and roughly 10% to 20% will be for switch. Okay? And my guess is that the CPO will start from 100 terabit very high-end switches. And according to my information or my opinion, the number will be the several few 100,000 pieces per year. And accordingly, so we need our optical engine, 16 times of our switching module. So it makes several million pieces per year. So probably like 28 or 29 times, 27 or 28 times. Right? So our manufacturing capability, I think it is doable by using the multiple lines among. This is my perspective.
Sounds great. So the AJ-san?
Yeah, I would look from the other angle. We're talking about scale up or scale out, and the problem in this scale out and scale up, we have to consider one factor is protocol conversion. When you go to the protocol conversion, then latency happens. So the goal is to pursue the optical from chip to chip and to the GPU to GPU. So I look at the CPO from the broad view. And so if you look from this angle, the CPO will continue to grow. For example, probably next step, NTT would do with Broadcom, like a plug module transceiver with the CPO. And so answer your question about the size, I look at the overall size, not only like one component, but I think from chip to chip, board to board, everything, CPO will be very important technology. That's what I look. Yeah.
Okay. Thank you. Okay, so second question is around Edge AI. Currently, most AI processing is performed via the cloud. However, the proportion processed at the edge site is gradually increasing, maybe you know. And it is forecasted that around 50% proportion is covered by the edge site in the late 20s, maybe. And under that kind of the condition, in what areas do you see CPO technologies or or companies' products making the significant contributions to this market conditions? So this time, Tomizawa-san.
you very much for your question. Yeah, we are aware that kind of tendency, the edge processing started. So looking at the AI processing, I think it can be categorized into two parts. One is the machine learning, and the other one is the AI inference. AI inference could be done in edge processing, and partly because of the requirement of a low latency. However, still we need our machine learning, very, very heavy processing. And still we need our data center cloud machine learning across over the GPU to GPUs, server to server, data center to data center. So still we need our CPO solution, and are a little bit relaxed from the current requirement, but you saw the curve is like very steep skyrocketing.
Yeah.
So I think could be no change for the importance of the CPO solution.
Okay, so AJ-san?
You're asking about the age? Edge,
yes.
Edge AI. We have a subsidiary. Name is Edge Core. Try to promote my company's name. So when we created a company called, there's no fixed core. There's no permanent core, and there's no limit age. So if we look from the other way, they say the training or inference probably is more easy to answer your question. And I think AI edge will be everywhere. It's how good we are, again, to create the most cost-effective device. In this, we are working on another project, it's the access router. Access router combined with the camera. And we work with one of the Japanese customers, it's a historical site. So the camera would just to watch what happened and to prevent the fire. And so I believe edge will be everywhere. And inference will be also have the different type of application. So again, it's no limit of edge. That's what I guess. That's why to working as an open partnership is so important. It just remind me as such what happened about Tesla. When you think about Tesla being so successful, but the Tesla, when Elon Musk started to do the Tesla, he opened all the IP. He said he want more the EV, not only him, which is just echo what the Ram just said. More competition, more open. And if we can make this happen, I think edge AI will be unlimited. Am I right wrong?
That's good.
Great. So Rama-san?
I think it's important to realize two things. One is, if you think about it, today, generally when you hear a lot about cloud computing, right? Cloud computing is a virtualization use case. Because think about what happened in cloud computing. People said, hey, my CPU is not being fully used, so I want to run multiple applications on my CPU, so I virtualize it. Right? So it's essentially running multiple applications to increase the utilization of a CPU. Whereas when you think about machine learning, it's the opposite, which is any one accelerator is not large enough to run the workload. So you have to have many of those working together as if it's running one large system, right? That's what even high performance computing was. So first, once you realize we're moving from a world of cloud computing, which is virtualization dominated, to a world of machine learning, which is a distributed computing system. In the distributed computing system, network plays an extremely important role, right? Now the distributed computing system could be doing training, in which case they're running in very large data centers in the middle of nowhere in the world. Or eventually these distributed computing systems are actually doing inference, because even when you're doing inference, they have a cluster of 100, 200, 500 plus, even 1,000 plus. Because when you think about inference, there's two kinds of inference. Inference which is just trying to give you an answer, or inference that is actually, what you call reinforced learning into training. Okay? And really, a lot of people are doing inference for reinforced learning because the whole idea there is that we've run out of useful information on the internet, so you have to create a lot of useful information. So there's different kinds of inference. But long story short is we're in the world of distributed computing, whether it's inference at the edge, inference someplace else. And network is a computer. And copper is not going to suffice going forward. And you need optics to come solve this problem. And you need something that is cost efficient, power efficient, and scalable in volume to bring together all the compute that's expected, whether it's at the edge or in the middle of nowhere in a desert.
Okay, thank you. Okay, so the final question is business partnership. Looking back over the past few weeks, we have had several announcements regarding the partnership between the semiconductor-related companies in Japan and the United States. As you move forward with the market deployment of the CPO technology, which player do you believe you should strengthen the partnership? Of course, besides your three companies. And additionally, on top of that, what aspects of your own company would you like to highlight to that potential partners? So, start from the AJ-san.
It's a very tricky question. Actually, to me, partnership is very important with the trust and with the capability and with the long-term partnership. So it's not easy to find. Maybe you can find a startup, they have good technology, but they don't have a long-time history, a partnership relationship, or maybe they have a very narrow technology, narrow coverage. But to me, NTT and Broadcom technology is good for me to keeping me very busy. Yeah.
Okay. I think, or rather, we are living in a world right now where the cutting edge of technology is being built, the most cutting edge of technology, and some of the hardest technology is being built. So we would like to partner with somebody who has the cutting edge technology, who's bringing these to market at scale, and obviously with the quality that's needed. That's one. And two, I will tell you, you might not like this answer. I want to partner with somebody who has a lot of money. Because if you think about what's happening in this world of AI, people are talking about $500+ billion of capex being spent just by 4 or 5 of the cloud players today, right? And you now talk about the amount of gigawatts of data centers that are being talked about, 200+ gigawatts of data centers. You're talking trillions of dollars that are needed, all the way from these people who are building these large mega scale data centers down to people who are building fabs and people who are building coolers and chillers and factories and everything else. I think for this AI world and everything that we've talked about today to be realized, you need people who have a lot of money. I think some governments have a lot of money, so I'd like to partner with them along with these companies.
What do you, Tomiza-san?
Yeah, thank you very much. Definitely, we need a collaboration with the end users. Mm-hmm. For example, hyperscalers and as well as the neo cloud player. Mm-hmm. Without this kind of collaboration, it is very difficult to go forward. And actually, we are already communicating with the potential end users directly. Sometimes jointly with Acton, jointly with the Broadcom. But this kind of early engagement is indispensable for get launched into the new market. And the second collaboration, we need a collaboration with the processor guy. Mm-hmm. Actually, we are get started with the processor guys, like a big processor guys. Mm-hmm. And because the PEC 2 or PEC 3, we should consider the integration with the processing circuit. For this purpose, we need some early engagement with the processor guide as well. Number three, according to our Q&A session, I described with some potential competition and collaboration with our potential competitor. Because as Ram said, the market is huge and every end user needs a multiple supplier. So in that case, we need like a agreed interface, agreed specification in some standardized way. So these three are very important for the collaboration besides the three companies.
Okay. Yeah. Thank you for the clear answer. So now we had very insightful voices from the three companies around low power devices required for the AI era. Especially we learned about that against the limitation of the electronics processing, the PEC and the CPU switches is mandatory to conquer this kind of the physical situation. And on top of that kind of the technology advancement, the ecosystem, I mean the collaboration across the let's say important and less important even stakeholders depends on the situation is very important to this let's say high-speed changing ICT market. Yeah. So again, thank you Tomizawa-san, Ram, and the AJ for the very insightful real voices. Thank you. So I'd like to close this panel and having the question from the audience.
はい、ありがとうございました。
Thank you very much. From here, we would like to take questions from the floor. How we will be taking questions is what I would like to explain. First of all, for the questions, from the media relevant people who are here at the venue and like to receive the questions, followed by questions from the investors from this venue. And after that, for those of you who are connected to the web system online, remotely, would like to take your questions. For those of you in this venue, the staff member will bring the microphone, so please raise your hand. For those of you who are participating remotely online, those who have a question, please press the raise your hand button on the web system. And once you receive the request from our side to unmute, then please unmute and ask your question. After you ask the question, until the answer from our company ends, please remain unmuted. So thank you for waiting. We would like to take questions from the media people who are present here at this venue. You can ask your question either in English or Japanese. For those of you from the media, are there any questions? Thank you very much. Then from you, please, over here. From Nikkei, I'm Takatsuki. Hoshino-san made the presentation as NTT. Why Broadcom? This time, in the production of a PEC device, they're going to collaborate with you, because they have their own proprietary solution that's being developed. What kind of a meaning, significance does this have? I would like to know that.
Yeah. Look, I think if you look at this switch, this is what we do. It's a 100 terabit switch. And when you look at it closely, you'll basically see it has a lot of I/O coming out of this, right? And when we partner with the ION team, we look at it as we want to make sure Broadcom wins in the switching business. And for us to win in the switching business, we very, very strongly believe in the idea of openness. So Broadcom never has actually created vertically integrated solutions. Every time we've created products, we made sure they're very clean, open, standards-based interfaces, and that multiple partners can actually build their solution and ecosystem around us. So what we tell our customers is, let the best product win, okay? Because if you think about it, we build our switches, but if our optical technology is not the best in the world, we don't want to lose the switch business to somebody else because we don't have the best optical technology in the world. For us, the optical technology is an enabler and is just one part of the ecosystem. So as long as the ION team is able to produce a device that's at least as good or as better than us, we want them to win, okay? That's extremely important. And because at the end of it also, our end customer looks at it and says, if they only have one vendor, they don't want to buy the solution because they'll think of it as, hey, Broadcom is vertically integrated, and if I work only with Broadcom, I cannot make this supply chain very scalable. So it's in the interest of Broadcom as a company to make sure the ecosystem is very, very successful. So Tomizawa-san and NTT ION has access to all the same specifications on our switch that our internal team has access to, which is why their ability to win or lose is purely a function of their technical capability. It has nothing to do that Broadcom has both these products. And also one quick thing I mentioned to you about Broadcom is we are a large company, but inside the company we are very distinct technology business units, okay? And my business unit builds the switches, another business unit builds the optics. From my business unit standpoint, I don't care whose optics win. I just want to make sure I have the strongest ecosystem surrounding my switch. So it actually creates a very healthy ecosystem.
はい、よろしいでしょうか。はい、ありがとうございます。
Thank you. I hope that answers your question. Any other media participants in this room? Please wait for the microphone.
Technology journalist. I have two questions for the Ram-san and Juan-san. And first of all, the Ram-san says the Tomahawk 6. My question is about the Tomahawk 6 has the connected with the 512 XPU. Is this a limitation of the such as XPU connection of the XPU? Do you have the some kind of the prospect for the future of the breakthrough of the limitation?
Okay. So the question was, when we showed something like a Tomahawk 6, why do I have a 512 number? Okay. When you're doing a scale-up cluster, you want to make sure there's only one switch hop from one XPU or accelerator to another one. Okay. You can always create a larger cluster by creating a two-tier switching architecture. But for scale-up, you want to today keep it to a single tier. That means just one switch hop, accelerator, switch, accelerator. Then you look at the switch and say, how many links does this switch have? This switch today is 100 terabits, and each link is 200 gigs. So you have 512 200 gig links. So I can connect to 512 XPUs. But when I connect to 512 XPUs, because I cannot put it inside a rack, I have to put it across multiple racks because each XPU takes a lot of power. So I'll put it in multiple different racks, and I'll have, these switches connecting directly with one hop. Okay, so that's what limits it to 512. We have 512 200 gig SerDes that gives you 100 terabits. And then, as you can imagine, in the future, we'll have higher bandwidth. That means you'll have higher lanes at 200 gigs, and then you will increase the cluster size of the scale-up.
Thank you very much. And the other question is about Mr. Huang. I am very impressed with the network of the university and hospital and data center. But why did you select the data hospital? This is very strange situation compared to Japan, because many of the hospitals has a lot of the individually specification. So connection is very difficult, very tough. So So I'm very strange of the you are easily I'm not sure, but easily or connected to the hospitals, to data center and the university. What is the reason why you selected the connection of the hospitals? The hospital has a lot of the privacy or some privacy information. It's very difficult to do this in Japan.
Thank you. This is a very good question. And actually, it's two questions here, right? Why I chose hospital? And the reason is hospital is very critical in our society. And we want to help the hospital, they can utilize more AI. I think that this happens to every hospital. So hospital or the medical, they want to combine the AI with medical, right? This is what happening now. Of course, according to my experience, the gap between two parties is very, very big. Medical doctor, they don't want to learn the IT. And the IT people doesn't understand medical doctors' concern, right? Because you are right, the medical have a lot of regulation, rule, it's not easy. So what we are trying to do is to build the infrastructure first. So this is what I just mentioned in my previous presentation. Probably I didn't make myself clear. We want to build infrastructure. And Ren mentioned about AI is networking. Networking is AI. Without networking, AI becomes very difficult. So what we try to do is build the infrastructure. The same concept is for whole Taiwan. So I try to explain to the people who I know in high level of government. I say no AI infrastructure is no AI. So this is the first one, your question. And the second one, why I want to choose this hospital? Actually, because I'm the member of this hospital. So this hospital is a charity, belong to a charity foundation. And I'm the member of this charity foundation. So to me, I just try to do everything I can to help them to build the infrastructure. This hospital, they have a hospital in a very remote area, and a very small area, very small hospital just help the remote area. So I want that small hospital can also use the AI in the main hospital. So this is the idea come from. Yeah, very good question. Yeah, thank you.
ありがとうございます。
Thank you very much. So for those investors that are here at the venue, I would like to receive your questions. Any questions from your side? So the person in the back room. My name is Tokunagawa from Daiwa Securities. I have two questions. The first question, sorry that I'm repeating. The solution of Broadcom's and NTT's solutions from the question is from the competitive perspective. When I compare the two solutions, what are the strengths that each one has? And is there a difference in the approach towards the CPU or strategy difference? Can you comment about competition? And the other is the production capability. Looking at Tomizawa-san's presentation, you were saying 5,000 units per month as the capacity. If there is a larger demand, I think you need to speed it up a bit more. But what is the bottleneck to do that? Is that a customer issue or is it the production line issue? Can you answer those two questions? In Japanese? Yes, you can answer in Japanese. The difference between us and Broadcom, as mentioned in the presentation,
we have the optical engine that can be replaced, meaning that if one optical engine fails, the whole product does not need to be repaired. So it's a low repair cost. And also, we can flexibly respond to various media requests. Or if the rack needs to be transferred, we can actually respond to that as well. The composition changes, we can respond to that. And that's our strength. And on the other hand, regarding Broadcom, the timing was slightly a bit ahead or before us. Maybe that is the difference. And also, sorry that I'm talking about our benefits. So 400G per lane, we're already working on the next generation technology, and we are receiving various inquiries from various customers. Well, but PEC up to PEC 4, we don't have other companies that have a roadmap up to there. It's a one line, 5,000 units per month currently. But if we make it 2 lines, 3 lines, 4 lines, it's going to multiply by 2, 3, 4. So basically, the visible demand we have right now, we can fulfill that, is what we think. But the number one challenge is that, and also this actually is our benefit as well, the connection of optical and photonics and fibrous connection at that speed, we have the strength there, and I believe that that is the benefit and the difference with others. Thank you very much.
So any questions from the remote participants? Please use your raise hand button function. Anyone? Okay. Anyone in the room? Okay. Please wait for the microphone. Masuno from Nomura Securities. I have 2 questions. So FY23 innovative devices establishment. Since then, you said you will start the mass production in FY25 and 200 billion yen sales in Q4, commercial shipping, and mass production 27, you're saying. So is this a postponement of the timeline, or are you talking about something different? When the company was established, the image has changed or not? And my second question is NVIDIA quantum switch. We don't know when their quantum switch will come, in what volume, but looking at supply chain, there are 12 companies inside. And this time you're working with Acton and Broadcom partnership. But are you thinking of a larger ecosystem going forward? Thank you. Okay, may I? So when the company was established, we had that roadmap, the plan. But there were various circumstances. For example, the semiconductor crisis. Our customers in FY22 and FY23, they bought our products in big volume. And it became their inventory. And so customers needed some time to clear their inventory. And that is why our sales dipped a little and was pushed back a little. And we are NTT subsidiary. So the US-China issues was a factor. And so our advancement into Asia did not progress as much as we anticipated. And so the existing part did not progress as much as we expected, but the development of PEC 2 and PEC 3 are progressing as scheduled. So no change there. So I hope we could understand. Now, NVIDIA as partnership. Of course, we are aware of that. And the manufacturers, companies in that group are not saying that they're exclusive to anyone. For example, the two companies we have here on the stage are the two, and including the end users. We are having various discussions, so we will continue discussing with NVIDIA and among others. And so that is not the only option for anyone. So our three companies are very close now, but going forward, the processors and end users, we will evolve and talk with many others. We are working right now. So I hope you could have high hopes. Thank you very much. Thank you. That's all from me.
Sure. I think to your question about NVIDIA quantum and stuff, if I know correctly, quantum refers more to InfiniBand than Ethernet. What I would say is what you're seeing here is a technology partnership on technologies like Ethernet, which are very open technology. And even the whole discussion about Broadcom versus NTT ION just kind of shows you the only way you're going to scale to hundreds of gigawatts of data centers being deployed is having an ecosystem that works around standard interfaces. Because otherwise, you cannot scale to the amount of opportunity that is out there. So we collectively, as an industry, have come to the conclusion, if you think about it, a few years ago, people said, if you want to build a large machine learning cluster, you have to build it with InfiniBand as a technology, right? But today, the entire market is building them with Ethernet as a technology because Ethernet is the only one which is open standards based. So that is the most important thing I think for you to take away is it is a very large market and there's a massive transition that's going to happen from copper to optics. And this requires multiple companies work together. In some places you compete, some places you're going to partner. But that has to happen for this market to explode. Otherwise, if you're vertically integrated and trying to do everything yourself, this market will not happen.
Thank you very much. ありがとうございます。他ご
Are there any more questions? If not, we would like to conclude this session. For the panelists, please give them a round of applause.